So your y-intercept is 3. Now, when you are standing on the y-intercept, you have to see how much you go up. You will go 2 units up from the y-intercept and 1 unit right from there. Now you can see that there are 2 points. One was your y-intercept, and the second point where you have reached after measuring your gradient. Now I'm ready to draw my straight line. Let me take my rulers. Yes. Now, guys, you can easily draw the line passing through these 2 points. So this is the rough sketch. Uh, in sketching, there are features. Number one, examiner may ask you, what is the y-intercept? What is the x-intercept? So y-intercept, you need to put x is equal to 0 into the equation of the line. So when you put x is equal to 0, it gives you y is equal to 3. So the line cuts, it is all obvious from the equation that the y-intercept is 3. Now to get the x-intercept, where the graph cuts the x-axis, you need to put y is equals to 0. And when you put y is equal to 0, you get an equation in x, solve it. It tells you that your x is minus 1.5. So in this way, guys, any linear function can be drawn. I can make one more example with the negative gradient. For example, if the examiner gives you y is equals to minus 3x plus 4. Now you want to draw this graph. It is obvious we are going to draw, this sketch. This is negative 3, which is my gradient. As it is minus 3 over 1, it tells you 3 down and 1 right. So where shall I stand? I stand on the y-intercept, which is given to me 4. 1, 2, 3, 4. So I'm standing on my y-intercept. As per the rule, from the y-intercept, I need to travel 3 units down. So if I move 3 units down, 1, 2, 3, and then I need to move 1 unit to the right. So I stop here, and that was my initial points. After plotting or highlighting these two important points, I'm ready to draw by using my ruler tool the sketch. So this line which I have drawn, it is representing y is equal to minus 3 plus 3x plus 4. I remember in linear programming, you guys have these type of questions like 2x plus 3y is equal to 6. And we want to draw such type of a line. Um, it's quite obvious if you substitute x is equal to 0, then the equation will turn into 3y is equal to 6, and then y will be equals to 2, and you will have 0, 2 point. And if you substitute in the second time y is equal to 0, this will take you to get the value of x, and now I got the another point which is 3 0. And then after that, my friends, you will plot these points easily. 0 2, 0 2, this is your point, and 0 3. And then also you can draw the rough sketch of this line. But this is used in linear programming. He's not going to ask you to sketch this line. But why did I explain it to you? Because maybe you will use this technique in linear programming. Anyways, this was quite familiar thing, graphing of linear functions. Now I'm going to take you guys towards the sketching of quadratic functions. So this is my second objective, how to draw the quadratic functions. Linear functions, when we draw them, we always get a line. That's why we call them linear functions. Quadratic functions, you need to know what type of function is a quadratic. So, my friends, y is equal to 3x squared plus 5x plus 2. Since the maximum power of the variable is 2, that's why it this is called quadratic function, quadratic polynomial of degree 2. Or if I put them equal to 0, then I call it as a quadratic equation. And you all very much familiar with how to solve the quadratic equation. Yani, solving a quadratic equation graphically means you are finding the x-intercept where the graph cuts the x-axis. Anyways, so how to plot or how to sketch, sorry, the quadratic function. So in quadratic function, when you look at that, this plus 2 is a straightforward y-intercept. Yani where your graph cuts the y-axis. It will cut at 2, yani 0, 2 point. Now, do we have any gradient concept in quadratic functions? The answer is no. There is no gradient concept. Quadratic function, when you draw it or you sketch it, it looks like this type of a shape. And these shapes are parabolic shapes. They are parabola. Only there are two parabolic shapes in your course, vertical parabolas. One parabola is facing up and one is facing down. You can understand it's a smiley face and the other one is a sad face. So if the parabola is facing up, how will you come to know that the parabola is facing up? This will be known to you when the coefficient of x square is positive. Like I am going to draw the parabola if the coefficient of x square is positive. So a is greater than 0, then my parabola will be facing up. And if the coefficient of x square is negative, then my parabola will be facing down. Okay, so two important things are revealed from the standard quadratic function, which is ax square plus bx plus c. But now I'm going to explain that how standard quadratic function can be converted into completing the square form. It will provide you further more information which will help you to sketch the graph. So let's do how to convert any any uh, any parabola. If you want to sketch it in the exam, let me make it easier for you guys. 4x and minus 2 supposedly, and examiner says can you sketch it, but since it is the standard quadratic function, the standard quadratic function, I need to convert it into completing the square form. Completing the square form is like this, boys. You have a plus sign here, you get a plus sign, you have to write something here, plus something here. How can I get these numbers? This is A and this is B. What do you need to do? You just need to take the derivative of x squared, which is 2x, the derivative of 4x, which is 4, and then put it equals to 0. And the derivative of minus 2 is 0. No need. Once you get the derivative, you get the value of x, which gives you minus 2. Now this x is equal to minus 2 will be substituted back into the original equation of the function to get the corresponding y value. So 4 minus 8 minus 2. So 4 minus 2 is 2, 2 minus 8 is minus 6. So I got y is equal to minus 6. Now, my friends, the x value and the y value is found. This x coordinate and this y coordinate is a very special point. This point is a turning point. This point is a turning point or a stationary point, but we will call in the language of graphs, this will be the vertex of the parabola. Now, if I draw my x-axis and y-axis, boys, if I draw my x-axis and y-axis, where is minus 2? This is minus 2 and this is minus 6. So I have plotted the uh, the vertex, which is minus 2, minus 6. Now, where the graph cuts the y-axis, you can easily see the y-intercept from the standard form, which is minus 2. Now I'm ready to draw the parabola. So parabola's vertex here, it cuts from here. And now the symmetry of the graph tells you can complete your graph like this. If you want to find these 2 points where the graph cuts the x-axis, then you need to solve this equation by putting f of x is equal to 0. So x squared plus 4x plus 2 minus 2 is equal to 0. You just need to solve this equation. Will give you the two values of x. These two values will be the x-intercepts. So sometimes the examiner asks you the x-intercepts and also he asks you the y-intercept. He calls them A point, B point, and C point. So you can easily find the intercepts from the standard form to the completed square form. So completed square form method is very important for the parabola. Now I come to the last topic, which is so now I'm going to explain you another important graph, which is the cubical function. I think in my whole explanation, you must say that this is the most important one. So cubical functions, and you need to put focus on this cubical functions more. Because I see nowadays the examiner is asking you cubical functions. So how he will give you the cubical functions? He will write, for example, x minus 1, and x minus 2, and asks you to sketch it. Now imagine this function is a product of three linear factors. Check it out. X minus 1, and x minus 2. So this is the product of three linear factors. What I need to get, guys, I need to get the x-intercepts where the graph cuts the x-axis. So for this, I need to put it equals to 0. So x is equal to 0. Getting this factor, the second factor is x minus 1. I put it equal to 0 and I get the value of x, 1. And then the third one, again, in the same way, you substitute, put it equal to 0 and get the values of x. So you got three critical points. Now, these three critical points are standing where? They are your x-intercepts, where the graph cuts the x-axis. So keep it in your mind, we are not drawing, we are sketching. So in sketching, I am heavily relying on what? I am heavily relying on features of the graph. So what are the features of the graph? X-intercepts and the y-intercepts. Now, very quickly, I saw the factors and I put every factor equal to 0. It gave me three critical points. So let me plot these three critical points x on the x-axis: 0, 1, and 2. The linear function is a line. Quadratic function is a parabola facing up or facing down depending upon the coefficient of x squared. The third thing is a linear function. Now the cubical function. So the cubical function, guys, you need to know where the graph cuts the x-axis. So the cubical function, it has two types. Maybe the curve comes from the right and go to the left downward, or if it comes from upward on the left hand side and then it goes down. In Arabic, you call it madda, alif madda. Okay? It's a madda graph. You can, if you want to understand the quicker way of memorizing how the cubical graph looks like, it looks like madda. Okay? Which you use in Arabic language. Okay? So now your graph comes, it hits the x-axis at 2 because you have found your x-intercepts, and then it turns back, hits the x-axis at 1, and then again it hits the x-axis. So 3 times it hits the x-axis at 0, at 1, and at 2. So this is the sketch. Examiner will give you the marks for that. Now, if examiner gives you this type of a function, it might surprise you. What is the surprising package in this function? Oh, we see x plus 2 whole squared. So this factor, I will call it, it's 2 times repeated factor, or it is a repeated factor. How many times? 2 times. What will happen here when the graph approaches to x plus 2? First, get your critical points. Put every linear factor equals to 0 and get your critical point. X is equal to 1 and x is equal to minus 2. You will definitely ask Mr. Omar, Mr. Omar, the cubical function, the previous one, you said that the graph cuts the x-axis 3 times, and now it is cutting the x-axis at 2 times. So what is the problem? There is no problem, man. I will show you what happens to the nature of the graph when I will plot it. So let me draw my x-axis and y-axis, boys. So x-axis, y-axis. Okay. What are the critical points? X is equals to 1 and x is equals to minus 2. If I multiply these linear factors, definitely the coefficient of x cube will be positive, so the graph will be like this. But since your graph is repeated here, whenever you see your graph is repeated, so repeated graphical terminology is the graph will be touching here, not cutting. The graph will be touching here. And if it is like an odd power here, just a single factor, so the graph will be cutting here. So in the beginning, in the IGCSE exam, when this question comes, if you see a repeated factor, it means the graph will be touching here, no cutting. But if it is an isolated factor, a single factor, then definitely it will be cutting. So I know you guys are hoping how the graph looks like. It comes from here, it cuts at 1 because that the power was 1, and now it goes all the way and it is touching. Imagine it's not cutting, it is touching. So I have to show the touching at minus 2 because the factor was quadratic, and it's power 2. So it's touching at 2. The graph looks like this. I want to give you very quick examples. If examiner says x minus 1 whole squared and x minus 3, so the linear factor is x is equal to 1 and here is x is equal to 3. Very quickly I can draw. Critical points 1 and 3. My graph comes from here because if I multiply them, the coefficient of x cube will be positive. So the graph comes, it is touching here since there is a power 2, and the graph will be cutting at 3. So here you go. I'm going to come and here it is touching at 1. So this is touching and this is cutting. There are scenarios when examiner can write like this: 1 minus x and x plus 3 x minus 2. Imagine this linear factor, x is positive, but unfortunately in this factor, the coefficient of x is negative. Now this madda will be opposite. This will be like this. This is the only thing. If you see x negative, then get your critical points first. So this will give you x is equal to 1, this will give you x is equal to negative 3, and this will give you x is equal to 2. Now, we want to draw the graphs. So 1 minus 3 and 2. Now, instead of the graph coming from here on from the right hand side, it will come from the left hand side. It cuts at minus 3, cuts at 1, and cuts at 2. So the graph looks like this. But the repeated factor has been explained to you in detail. Boys, I discussed with you the cubical functions, the quadratic function, which looks like a parabola. Very quickly, if examiner will give you this type of a shape, minus x squared plus 2x plus 1, you will say, since the coefficient of x squared is negative, the parabola will be facing down and it cuts the y-axis at 1. Cuts the y-axis at 1 because this is the y-intercept, and this tells you the parabola is facing down. But if it is x squared plus 2x plus 1, then very quickly you say that the y-intercept is 1 and the parabola will be facing up. Why it is facing up? Because the coefficient of x squared is positive, so the graph will be like this. But to find the vertex, you have to convert it into the completing the square form. So the linear function is explained, which depends upon gradient and y-intercept, quadratic function, cubical functions, and now there are some famous sketches, trigonometric functions in your IGCSE course, trigonometric functions. Since 2020 till 2022 March exam, examiner tested students by giving them sine graph, cosine graph, and the tan graph. Sine, cosine, and tan graph, they are always drawn with the range from 0 to 360, boys. And in trigonometric function, the step is always 90. Step is always 90. Sine graph is completely wave. It falls between 1 and minus 1. You cannot extend the wave beyond 1 and minus 1. So just draw the sine graph at 0. We get 0, 90, we get 1, 180, 0, 270, minus 1, and 360. So it's complete wave, the sine graph. Cosine graph doesn't start from 0, it starts from 1. So it doesn't look like a wave, but it's a wavy nature. It has a wavy nature if we extend the range. So it starts from here, a quarter wave. You can see here half wave, and a quarter is here. This is a cosine graph. By the way, you guys can use the table function, but step has to be kept as 90 degree. Your start is 0 and your end is 360 degrees. Tan graph is amazing. At 90 degree, the calculator gives me an error. Error means the graph cannot cut 90 degree and 270. And they are, in mathematical terminology, they are called asymptotes. So the graph can get closer to them, but they cannot cut them. So look at that. It's again cubical function like a madda graph. So these are the three trigonometric functions in your course. The fifth one, immediately you need to understand f of x is equal to x squared or f of x is equal to minus x squared. Examiner might test you. It's a parabola. The vertex is at 0, 0. And f of x is equal to minus x squared. Parabola is facing down, cutting at 0, 0. It's facing down. I have seen examiner also gave these type of function x minus 2 whole squared and x plus 3 whole squared. What is the critical point? The critical point is x minus 2 is equal to 0, x is equal to 2, and from here x plus 3 is equal to 0, x is equal to minus 3. So I got my critical point. Imagine there is a power, so it is touching. It is also touching here. So let me draw 2. Where is 2? This is 2. So the graph is touching it since a parabola. It's touching at 2. And again, I'm ready to draw this sketch. Minus 3. The graph comes from here and it goes up. In cubical functions, I remember examiner was also asking student where the graph cuts the y-axis. Guys, if he asks you where the graph cuts the y-axis or the y-intercept, put x is equal to 0. So if you put x is equal to 0, 1, um, uh, this is 3, and this is minus 2. So it tells you minus 6. So graph cuts at minus 6. So don't worry. To get the y-intercept, you need to put x is equal to 0 into the original function. After explaining you this question, yani fifth part, and then our sixth one is sometimes the examiner gives you the reciprocal function 1 over x or minus 1 over x. The reciprocal function, they are basically hyperbolic shape. Yani hyperbola means the flaps are here and here. More than one times, examiner has asked this sketch. And minus 1 over x, how does it look like? It is the graph like this. Seventh one, y is equals to 1 over x squared or y is equals to minus 1 over x squared. If the equation is given like that, your hyperbolas, oh, this is touching the x-axis, don't touch it. So both are above the x-axis. And if it is y is equal to minus 1 over x squared, when you draw it, this graph is like this. Now next thing, I have explained it to you, the reciprocal functions. Did I forget anything? Yes, only one left, exponential function. So if y is equals to 2 raised per x, he asks you, or y is equal to 2 raised per minus x, how these graph looks like. Exponential graphs. The graph comes from here, it cuts at 1. So it comes from the right hand side and goes towards the left side and gets closer to the negative x-axis. On the other side, y is equal to 2 is from minus x. If you draw it, the graph comes from the left hand side and cuts at 1 and gets closer to the x-axis. So these are the possible graphs which may come in your exam of IGCSE regarding sketching. Thank you, boys. Assalamu alaikum wa rahmatullahi wa barakatuh.